Among the problems reported by many VESC users, the most common problem is the burning of the MOS tube. After checking the VESC parameter configuration, it was found that the problem was caused by incorrect configuration of the braking and recovery current. This video will briefly explain the principle of braking and current recovery causing board burnout, and further understand the harm of configuration errors through oscilloscope observation. Finally, it will show how to set these two parameters in VESC tool. When braking or recovering, the motor becomes a generator and generates reverse electromotive force. If the recovery current is set properly, the reverse electromotive force is absorbed by the battery or brake module. If the regenerative current is set too high or not limited, the back EMF will be superimposed on the original phase line voltage and bus voltage, generating a momentary spike voltage that far exceeds the rated withstand voltage of the MOS tube. The MOS tube will be broken down by the high voltage, which may cause the VESC to stop working at the least, or cause a power short circuit, smoke or even fire at the worst. Next, we use an oscilloscope to further understand the impact of this configuration. It can be seen that when the recovery current and brake current are correctly configured, the reverse electromotive force can be absorbed by the brake module or the battery. When the regenerative current is set too high, exceeding the brake module dissipation power, or battery charging current, the bus voltage and phase line voltage of the ESC will show abnormalities during braking. If the braking and regenerative currents are set too high, the bus voltage and phase voltage of the ESC may experience dangerous spikes during braking. If the working voltage of the ESC is close to the upper limit of the withstand voltage, this level of spike voltage will definitely destroy the MOSFET. Before configuring these parameters, let's take a brief look at some core concepts. Braking current is the active output when the motor brakes. It should avoid being too high and continuous. The specific value needs to be adjusted according to the fluctuation of the bus voltage. Regenerative current refers to the maximum value of current recovery, which needs to be set according to the current recovery capacity of the battery, or the dissipated power of the brake module. It should be noted that the regulated power supply has no current recovery capability. Therefore, when using the regulated power supply, the regenerative current can only be set to 0, and the brake module is used with the protection ESC. The bleeder resistor is a dissipator of excess energy. It needs to be enabled and set with the correct parameters and the voltage threshold. Next, we will take VESC tool as an example to show how to correctly configure these parameters. Step 1. Determine the maximum recharge current. Check the battery or BMS data sheet to determine the maximum charging current. If this information is not available, use half the battery capacity, and verify safety by observing the bus voltage. Step 2. Set the parameters in Motor Settings, General, Current. To ensure safety, set the battery current max regen to 0.5 0.8 times the maximum charging current. Step 3. Set motor current max brake. It is usually set to 1.22 times of the regenerative current, and the maximum value shall not exceed the motor operating current. Step 4. Configure the brake module or bleeder resistor. If the power of the brake module is too small, it will not be able to absorb all the current. Step 5. Write configuration and verify. Click Write configuration to upload the parameters. Then, perform a no-load test, and monitor the voltage changes using a host computer or oscilloscope. If configured correctly, the battery or brake module can absorb the full current. This video ends here. Thank you for watching.